Well, greetings, Mr. Colazar's class. We're going to continue in now in our last section, 12-5, looking at the phase diagrams as we look at going from different states of matter. Now, our phase diagrams are going to have to be able to read and interpret, so it's going to be a graph that has pressure versus temperature that shows which phase a substance exists in under those different conditions. So we can change, remember, the temperature and the pressure can be used to affect what state of matter we're in. So we'll have temperature down here on the x-axis and pressure on the y-axis, and as we change temperature and pressure, we're going to see which state of matter we're going to be in. So solid, liquid, and gas. Remember, gas is also known as vapor. So when you see vapor over here, we think of the gas. Our liquids, and a region where we would be a solid at. So those three. Now, the boundaries of these three changes are where the phase change is occurring. So as you're going from a solid to a liquid would be during, say, the melting phase. So we'd look on here, this line right here is where we would be changing the state of matter between solid and a liquid. So when we're melting, or liquid to solid, depending on the condition at the time. And then we could go from the blue line here, and moving on up, would be our liquid to gas or gas to liquid. So we'd be having our vaporization. And then there's a small chunk down here where we're going solid to gas or back. And our solid to gas would be our sublimation, going directly to a solid to gas without changing to a vapor. Or without changing to a liquid, excuse me. So as we're looking at these three during the line, that's when this change is occurring. And if we're in any of the areas, that's the state of matter we'd have depending on the pressure and the temperature of the material. Every once in a while, you'll notice where there's a little break and just have an extended period of the graph that's missing is all. Now, a couple points that are also included on the phase diagram are the triple point. So the triple point is where the temperature and pressure where they exist, where all three states of matter can exist or coexist. So there's going to be a point, triple point, right here, where all three states, if you're at this temperature, pressure, that all three states of matter exist together. So that's the triple point. And then another point that's on the graph, critical point. The critical point here is at this temperature and higher, no amount of pressure will change the vapor back into a liquid. There's just too much kinetic energy for the substance to be pressurized back into a liquid. So at this point and forward, they're all just gases. So as we're reading these graphs, depending on where you fit in the chart, will depend if you're a gas, a liquid, or a solid. And if you're a long line, you're changing phases. If you have to be at triple point, all three phases can exist. So a couple neat ones. Melting ice with pressure. So ice, 0 degrees Celsius is ice, and at 1 atmosphere, we're kind of, at 1 atmosphere, we'd be kind of at our freezing. Now, if we apply pressure from the blade of a skate, we increase that pressure, and as we increase that pressure, we move from being a solid to a liquid. And so when you skate, you're actually skating on a fine layer of liquid water. So that would be a way to see our pressure changing without the temperature or pressure changing a state of matter. Boiling under 100 degrees Celsius, so temperature 100 degrees Celsius, 1 atmosphere is kind of our normal boiling point. If we decrease that pressure, we can decrease that boiling point, moving it down. So boiling under, so a less pressure will decrease boiling point. So as we're looking there, the amount of pressure pushing down onto the liquid, as it's pressing down on the liquid, allows it to have less pressure, so then the boiling point would be decreased. And then solid to a gas without a liquid, when we're looking, example would be like dry ice. And as we're going to dry ice, it starts out as a solid. Instead of going to a solid to a gas, which normally things would do to a liquid, there's a certain part on the graph in which we can go right from a solid to a gas. And at that place, then we're going through sublimation. And sublimation is at the point when you can go right from a solid to a gas without changing into a liquid. And so that wraps up our phase diagrams. Remember, phase diagrams showing our temperature versus the pressure and what state of matter we're in, solid, liquid, gas. And if we're along one of the lines, our phase change is occurring.